Okay, we'll take a look at this particular system of system of equations. We're going to solve it just by graphing. I went ahead and grabbed the first equation here, x plus y equals to 5, solved it for y, found out that m is minus 1, the y-intercept is 5. That means we can go over here to this point right here, 5 for the y-intercept. We get that on there. And then we can go down 1 over, 1 down, 1 over, and so we end up getting a line that pretty much is going to match up like this. Let me go ahead and put that in there. Okay, and then let's go ahead and take a look at this other equation right here. We have minus 2x plus y is equal to negative 7. We'll go ahead and write that over here. Let's see if we can do this. We'll have negative 2x plus y is equal to negative 7. So then we'll just go ahead and add 2x to both sides to get y is equal to positive now, positive 2x plus 7. And then what we can do is say that we have an m here of 2 and then a y int of 7, 0, 7. So let's go ahead and go to 7, actually negative 7. If you look right there, let's go ahead and fix that real fast. We definitely want to get that right. Okay, so we have that fixed now here. We have our negative 7 here, negative 7 here. So we'll go over here to negative 7 on the y-axis. And this time we have a slope of 1, or excuse me, 2. So we'll go up 2 and over 1. That would be here. And again here. We're going to continue this process. We'll go ahead and put a line through that. I could probably just make the dots here. And I think you can see that we're going to hit right there. If I do one more, you can see it continues on. And this line, if I put a line through there, is going to hit basically right there, and that's the point 4, comma 1. Okay, so that's going to be the solution, because notice 4 plus 1 is 5, and also 2 times negative 2 times 4 is negative 8, plus 1 is negative 7. So this is your answer for that one. Alright, so if you want to take a look at this system, we're going to solve by substitution. We're going to take one of these equations and maybe solve it for x or y. I kind of like to do this one here so we have some easier coefficients. So we'll just go ahead and say that we have negative x is equal to 6 minus 4y. That's a 4y. And then we're just going to multiply both sides by negative 1 to get x equals to negative 6 plus 4y. Just move all the negatives over, and then what we have here is an equation 3x minus 3y is equal to 9. So I'm going to write that down here as 3x, I'll put this like this, minus 3y is equal to 9. Of course, this is x, so inside here we can write our little minus 6 plus 4y, and there's an equation, and all we have to do is multiply it all out. So we'll get negative 18 plus 12y minus 3y is equal to 9. Okay, so let's go ahead and take this equation now. We'll go ahead and add 18 to both sides and do some light terms here. So we get 9y, that's 12 minus 3, 12y minus 3 is equal to 9, and 18 is 27, so y is equal to 3. And since we have an equation here that says that x is equal to minus 6 plus 4y, we get x is equal to minus 6 plus 4 times 3 is 12, which means that x is equal to 6. So the answer is the point 6 comma 3. And we can see that if we do, let's see here, we have 6 minus 12 would be equal to negative 6. And 18 minus 9 is 9. So this is definitely the right point right there. I don't know why I made that line. One more example here. We can say that we'll solve this for y. So from the bottom equation, right there, you can see that we have that y is equal to 5x when you add 5x to both sides. Y is equal to 5x. Okay, and then what we're going to do is substitute that y into the first equation. So we'll have 1 half plus 1 over 1 half x, sorry, 1 half x plus 1 over 5 times, well, 5x is equal to 3. Those 5's will cancel, so we have 1 half x plus 1x is equal to 3. So that's, well, if we take that, that's 1.5, or 3 halves. 3, that's a 3 halves. X is equal to 3. So then what we'll do is say that multiply both sides by 2 to get 3x is equal to 6, so therefore x is equal to 2. Okay, so then we have the first coordinate, which is 2. We know that y is equal to 5x, so then y must be 5 times 2, or 10. Using the substitution there, and we'll check it real fast. Let's see, 2 times 5, negative 5 is negative 10, plus positive 10 would be 0. Half of 2 is 1. Half of 10 is 2. 10 divided by 5 is 2. 1 plus 2 is 3. So that's your answer. Okay, let's go ahead and try and solve this system of equations here using the elimination method. So what I can do here is I can just go ahead and rewrite this equation. 2x minus 4y here is equal to 0. And what we're going to do is find some number. I'll change colors here to show you if I can do that. Some number that we want to multiply by in front of this equation. And I think what I'll do is use negative 2. Now the reason I picked negative 2, and notice I'm doing the whole equation, is when I multiply negative 2 times this positive 2, it will be negative 4, which will match up to that positive 4 down there. So that was the whole point of picking that number. It actually worked out pretty good. Let's see if we can get it to work here. Alright, so with that we would have negative 4x positive 8y is equal to 0. You can see that minus 2 times minus 4 is positive 8. And then we'll just keep the other equation the same. 4x plus 3y is equal to 0. And then when we add these straight down, this cancels that, and you get 11y is equal to 0 still when you add over there, which of course means y must itself be 0. And then we can install 0 in for x, and you can see 2 times 0 minus 4y has to equal 0. Let me go ahead and find some more room to work here. Let's get a little tight. Okay, you can see here, I took that equation, y equals 0, and I plugged in 0 for y, actually, right there. And then we have 2x minus, well, 0. 2x minus 0 equals 0, which means 2x equals 0, which means x also equals 0. So the point 0, comma 0 is our solution set. When I pull up another one here, it says, again, solve by elimination. And in this case, if you take a look at the two equations, though, we don't have anything that matches there for a single number. So we're actually going to maybe multiply both sides of this equation by a particular number. I'm thinking we'll take the first equation here of 3x plus 5y is equal to minus 13. And if I multiply this equation by thinking something that's going to give me, well, let's see if I just show you this and maybe it'll make sense. I pick this whole equation here, I'm going to multiply by negative 5, because that will make a negative 15 for the x. And if I multiply the bottom one by positive 3, we should be able to get something to happen. So we'll take that bottom equation here of 5x plus 3y is equal to 21, and we're going to multiply that whole thing here by positive 3. Okay, so if I do that, let's see what we get for a result here. Top equation. Okay, so our top equation becomes negative 15x minus 25y is equal to positive 65, and then we get 15x, and that was the whole purpose of doing this. Looks like plus 9y is equal to 63. Okay, let's go ahead and see if we can add these together here for the, well, that's going to cancel, so this is going to be negative 16y is equal to, oh, that's going to add to be 128. And then we'll want to divide by minus 16 on both sides. And I think you'll see that's negative 8, so let me just come over here and say y is equal to negative 8. Okay, and then if we want to plug that in for any one of these, we can just plug it into the first one. I think it'll be just fine. So we'll do 3x plus 5 times negative 8, because that's what y is. It's got to be equal to 13. Okay, so 3x minus 40 is equal to 13. And then we'll do, let's see what we get here. We're going to add 40 to both sides. So 3x will be equal to 53. I see, taking a look at this here, I forgot to take the count of this negative 13 right here. This is a negative 13. Negative 13 there, so that means that this number right here, 53, should really be 27. So when we put this negative right here, when we add 40 to that, we're going to get positive 27. There we go, and that means x is equal to 9. Alright, so then we have the point as our solution of 9 comma negative 8. So right there we have our solution. Let me circle a solution right here so we have it. Okay. Alright, let's take a look at one more elimination process here. I think I'm going to start with the top one of 7x plus 6y is equal to 3. And we're going to multiply both sides of that equation by a particular number here that's going to get me to minus 14. I'm kind of thinking 2. It's actually got to be positive 14. Let me explain why. Positive 14 and negative 14 will cancel, so we'll multiply that by 2. Let's see what we get when we do that. Right here we'll get 14x plus 12y is equal to 6, and then the other one has negative 14x minus 12y is equal to negative 6, and we add those down, we get 0 equals 0. What that tells me at this system right here is dependent. Okay, so if it's dependent, here's how we give the answer. We go ahead and make this curly bracket. Like this. And then we put in x comma y in parentheses, and then let the line. And then we write the most reduced version of the equation up there like this. Close the curly brackets. And that's what a dependent system answer looks like. Okay, that's the end of the first part of homework 3. We'll get back to that in a bit.